Okay. And then, let's see, the homework that was due today is what, drill 7, 8, 9, and 10, and then project
7
5,
and 8.
project 5. Well,
No. I mean the drill is 7 and 8.
7 and 8. And then
Yes.
I thought there were 2 other drills too. I think 7, 8, 9, and 10 were due today with 2 projects, right?
I will check now, but I think it was drill 7 and 8. I will check.
Looking at the course calendar. Course calendar is right here. So it's next week is 2 drills and 2 projects. 4 drills and 2 projects. Okay. So you said 7 and 8?
Yeah.
And then project what?
Project.
Okay, I see. All right, well, good. What's project 4? Oh, okay. All right, that's actually good news. That means I won't have to write as much. Hopefully I'm way better tomorrow. The doctor has me on 2 antibiotics, so but nothing I'm gonna die from, but I don't feel the greatest. So let's get through the assignments that were due today, and then let's talk about the assignments that are due next week, and I'll go through any sort of like special things that I want to make sure you are aware of before you do that, since it looks like next week is kind of the first week that, you know, the amount of code is higher. So we'll burn that bridge when we get to it. So let's see. Let me just bring up the stuff for today. All right, so you said 7 and 8 for today, correct?
Yeah, exactly.
Okay. All right, so let's start with, see, display reverse takes a list and displays the contents to the screen in reverse order. Okay, so let's flip over to this. You know what? I'm going to create a new file for our class. Let's call this guy CSC535. Let's call that good. Okay, so we want to have, and everybody can still see my screen? Or you can't see my screen? Have I shared my screen?
I can see. Oh, I don't know.
Okay. Okay, I got you. So you can see everything that's on my desktop.
Exactly.
All right, and right now you're looking at the Python stuff.
Exactly.
Okay, perfect. That's fine. Most people are muted, which is good. That way there's not a lot of feedback, but yeah, so when I ask a question, I'll expect there to be a little delay as you remember to unmute yourself after you've talked to your monitor for 20 seconds.
Yeah.
Right, so we have define display reverse, and this guy's going to take in a list as a parameter. So I'll happen to call my function a list. Or my parameter a list. I can name it whatever I want. And our goal is to display this guy to the screen in reverse order, right? All right, so we're going to, actually, hold on a second. Is it a list or a string that's coming in?
No, a list.
Takes a list of the parameter, displays the contents of the list to the screen in reverse order. Okay. So we're going to have our loop that's going to go through backwards. So we're going to start off at the length of a list -1. So that's the last legal position. And let's use better syntax here. In range. The length of a list is the last legal bucket in a list, all the way down to, but not including, bucket -1, and we'll step by -1. And then each time through, we will go ahead and display a list at bucket I. All right, so then to test this, we'll create a couple of variables. We'll say A is equal to, I don't know, A, B, C, and we'll we'll have B is equal to 5, 7, 13, 28, 91. So just a couple of different lists that we might want to call display reverse on. And then we'll go ahead and call display reverse, passing it my first list, which is A. So this list right here will get passed in as a list. We'll walk a list in reverse, displaying each of the things. So it should give me a C, a B, and an A.
Shouldn't the range be a comma instead of a semicolon?
Okay, yeah. So there's my C, B, and A. And if I just change the value I'm passing into display reverse, I'm passing in a different list. So this guy still works generically on whatever this list is. So this will print out a 91, a 28, a 13, a 7, and a 5. So there's our 91, 28, 13, 7, and 5. All right, that makes sense?
Yeah.
All right, anybody have any questions on that one? Okay. Next one. Comma code. Okay, so this one is from the end of chapter 4. Faster way of doing this. All right, so here's comma code. So assuming we have a list that looks kind of like this, write a function that takes that list as a parameter and returns a string. So we're going to be taking a list and building a string, and we're not printing it, we're returning it with all the items separated by a comma and a space with an and before the very last one. So this should be apples, comma, space, bananas, comma, space, tofu, comma, space, and space cats. Make sense? So what we want to do here then is we want to loop through everything except the last element in here, because this is a special case, right? When we get to this very last element, we want to treat that guy as a special case where we, instead of just doing comma space, it's a comma space, well, it's an and something. So we're concatenating something different. And so we're going to go through our list in some parts, and we're going to be building up a string that we intend to return. All right, and this guy is what called comma code. We'll define him up here. So define comma code, and he's going to, again, take in a list. So I'm naming this variable a list, but I can name it LOL if I want. I'm just purposely calling it something that is meaningful for what I expect it to take. So I expect comma code to take in a value that's a list. So that's why I've named him a list, okay? And I'm gonna be building up a string answer. I could call my answer anything else I want, but I'm gonna be building up a string. I'm gonna store it in a variable here called answer. All right, and then I wanna go through every element of my list except the last one. So I want to go through this one and this one and this one, but I don't want to do this one because I want to do something special for that very last guy in my list. All right, so each time through, I want to grab the element that's currently there and concatenate on a comma and a space. So here's my loop for I in range from 0 to length of a list -1. So that'll go up to and including the second to last element in my list. And I'll say answer is equal to answer concatenated with the value that's currently in my list. So that's a list at bucket I, followed by a comma and a space. All right, so this guy right here will go through everything up to, but not including that last guy. Then I want to treat the last guy in my list as a special case. Now, let me just actually show this to you quickly. I'm going to go ahead and I'm going to print out the result of comma code on A. So A is this A, B, C list that I have up here. All right. So this guy is going to go through, and it's going to go through the A and the B, but it's not going to go through the C. So this is going to produce a string that's going to be A, comma, space, B, comma, space, currently. And I'll just go ahead and return that answer right here. And we'll print out whatever comma code returns for that list A. So there's my A, comma, space, B, comma, space. All right, so I'm building up almost what I want, but now I need to do that very last element, or I have to say and space the final value. So I can return answer concatenated with and space concatenated with the last value in the list, which you can get by saying that, right? If you want to use a shortcut, but I actually prefer to keep things simple. One thing I dislike about Python, and you're going to see this as we get into the more complicated assignments, is I'll often use the primitive type things and not be aware of some of the 4 million different shortcut values. So you'll have to, clue me in on when I could have done something in a shorter way. But I like to keep programming as simple as possible. And I think sometimes when they give you too many power tools that allow you to do things that aren't overly complex, it becomes a problem. So I'd rather say I want a list at position, the length of a list -1. That's the last legal element in a list. The last legal A list value in A list is index its length -1. That'll get me the last value in there. All right, so I would almost always write it that way, even though you technically can say, I believe it's that. So even though it's shorter, I personally would call it not as good. And one of the reasons for that is, you've heard me kind of emphasize this idea that programming is the skill set. The language doesn't really matter. When you run into a language like Python that has all these little shortcuts and people use those shortcuts too much, it makes that code difficult to read for somebody who's coming from a different language, because they're all these little Python specific little shortcuts that might save you 6 or 7 characters, but make somebody like me have to do a Google search real quick to see what the stupid -1 means when you're passing the parameter. But do whatever you want. I've dealt with it long enough. I can look it up. I'm just kind of giving you more from a professional development perspective. If you're writing code, write it in the clearest way possible. It'll benefit people who are not necessarily familiar with your exact language you're working with, but who are programmers. All right, so there's my A, B, and C. Does that seem to solve the comma code question? I think so. Does that look right? Yeah. Okay. And then, which project was it? Project 4?
Project, let me check.
Project 10?
Project 4.
Project 4, okay.
No, we haven't reached 10 yet.
Yeah, but next week we're going to have 5 and 6. Okay, so project 4 is the fantasy game. So this is using what, dictionaries? All right.
This is, yeah.
Yeah, so let's go to the end of chapter 5. All right, so assuming we're creating a fantasy video game, so, kind of like Dungeons and Dragons, something like that, if you didn't know what fantasy game meant. The data structure we might use to model the player's inventory will be a dictionary. So dictionaries differentiate themselves from lists in that a list is a collection of things indexed from 0, 1, 2, all the way up to the length -1. where dictionaries are collections of name value pairs. You can compare these to something called a struct from older programming languages like C and C++, or you could also think of them as objects without functions. So basically, we index based on a value. So we might have a dictionary that has an arrow, and the value for arrow is 12. That is, we have 12 arrows. We might have another item called gold coin. So it's at index gold coin, we have a 42, for example. So let's see, they show us like, here's a dictionary representation of your inventory, where we have one rope, one torch, one gold coin, one dagger, and one arrow. All right. And actually, let me just jump over here just to save myself some. I don't have that selected. Automate the boring stuff. My clock is behind. Are you serious?
I think it won't. Yeah, it won't proceed.
I clicked. I clicked. Oh, it still thinks it's January something. Digital clock settings. Very helpful. Oh, whatever. I'll fix that later. None of those seem like any clock setting stuff. All right, let's go back up to this. All right, so the function we're writing, I was just trying to copy and paste this in, but I can't do that between these two OSs.
Try Control, not Command, Shift, and then V.
Yeah, that's what I'm saying, is I don't think it lets me do it between the two.
Okay, because I can do
My
it.
other one, I use Ubuntu for my other stuff, and Ubuntu lets me do it conveniently, but I was just gonna go to the website real quick and copy it. It's not the end of the world. So I'll go ahead and just create this the old-fashioned way real quick. So stuff equals, I'm gonna create a dictionary. We'll call it stuff. Now dictionaries look like this. Now we could add stuff to our dictionary one at a time, and I'll actually do that. I think that'll be easier for me to format. So I'm going to say stuff at position torch or position rope is equal to 1. Stuff at position torch is equal to 6. Stuff at position gold coin is equal to 42. Stuff at position dagger is equal to 1. And then stuff at position arrow is equal to 12. All right, so notice that instead of saying bucket 0, bucket 1, bucket 2, bucket 3, we're actually indexing our dictionary by a key value. So stuff at bucket rope is 1, stuff at bucket gold coin is 42. And if I print those things out, I say something like print out stuff, that'll show me the entire dictionary. But if I say print out stuff at index torch, like that, it'll give me the value associated with that key in my collection. There's my 6. That makes sense? Now, similarly, we can also spin through, well, I could say print out stuff, I think it's .keys. And that shows me all the different keys I have there. So I have rope, torches, gold coins, daggers, and arrows. Those are things I have in there. Similarly, I can go through all those. If I say for, we'll just call it key in stuff, and I print out keys, this will show me the individual keys that are in there as well. I can also cheat, and I can say key value, and I can print out the key, and I can print out each associated value from the dictionary as well. So this lets me get 2 different values from stuff, each key and its corresponding value. Is that right? I can say 2 things like that.
I think
I thought
I'm sorry.
2 things
Yeah.
like
I think you have to use the enumerate function to do that.
Oh, in enumerate, yeah. So it's key value in, what is it, enumerate
Enumerate, yes.
stuff. Yeah, there's the values. If you don't want to do this, that's fine. Let me show you the alternative to it, which would fall into the category of what I said before. So for key in stuff, print out key, and then print out stuff at bucket key. Now you have your key and you have your value. So there's both things. And frankly, I think this looks simpler than this looks. All right. But in any case, understand that dictionaries have 2 different things associated with them. They have a key and they have a value. And you can name them whatever you want. I could have called this guy LOL and then printed out LOL and then printed out stuff at bucket LOL. It doesn't matter what you name your variables. You're just encouraged as a programmer to name your variables something meaningful that, you know, means something. LOL is not a very meaningful variable name. Key was meaningful. It meant, oh, I have a key value pair inside of a dictionary, so key made sense, but you see this code works just as well. Okay. All right, so now that we have that brief introduction to dictionaries, what am I supposed to do with this guy? So I have an inventory. We want to write something called display inventory that is going to print out some stuff. So here's the other way of doing it. Inventory.items. I could have said stuff.items. So here's the third way of doing this. So all 3 of these for loops do the same thing. Pick your poison. All right. So we're supposed to write display inventory. This is going to take an inventory in as a parameter where inventory is going to be in this format, a dictionary of name value pairs. We're going to just print out the word inventory, and then we're going to have this item total we're going to be using, because at the end, I'm assuming we're going to have up the total number of things. A lot of times fantasy games, you think about like you're wearing a backpack and all of your gear is in your backpack. And you know, you have a total number of things. I have 1 rope, 6 torches, that's 7 things total, 42 gold coins, so on and so forth. Okay. And then they're gonna have us go through all of our elements in here. And they want us to have an output that looks, show us what the output might look like. Like inventory, and then we're going to have the value and the space key, the value, space key, so on and so forth. Okay. So, and we're calling this guy display inventory. So we'll go ahead and define a function. Display inventory. And we're going to have this guy take in an inventory dictionary. Okay, so very expressive variable name, right? This is a dictionary representation of an inventory. All right, first thing it's going to do is it's going to print out inventory. Right, there's our inventory. Then we're going to keep track of a number of items, so we can use the same variable name that they use. So item underscore total equals 0 if we want, or we can say something like num items is 0. Whatever we want to call our counter is fine. I'm purposely using a different value there to reinforce this idea that your variable names aren't dictated to us by Python. Variable names are dictated to us by our own imagination, and they should be meaningful for the kind of value we're trying to remember. Because remember, variables are our representation of things that we're remembering. All right, then we're going to go through every element in our dictionary. So instead of key value, they said for K, comma, V, so you can choose whatever you want. I'm going to say key value. Or if you want to be even more specific, we're going to call this item name and number of items in a inventory. We're not even going to trust myself to spell that right. In that.
You can tab it, auto-completes with tab.
Oh, does it in here?
Yeah.
All right. Well, copy and paste worked fine.
Yeah.
So my item name is going to be my key. My number of items is going to be my value. So I've chosen those two variable names because they're expressive for what I want. Now notice for my output here, they want us to have the number of items first, followed by the item name second. And we're printing this out because this guy, the name of the function is display inventory. So that kind of indicates we're displaying something, not returning something. So each time through, I'm going to print something. What am I going to print? I'm going to print the string version of number of items because I know that it's very likely numeric, right? It's like 6 and 7 and 2. So the string version of number of items concatenated with a space concatenate with the item name. I'll go ahead and print that out. So what did I just do? I printed out the string version of 12 followed by a space followed by arrow, for example. The next time through the loop, I'll print out the string version of 42 followed by a space followed by gold coin, so on and so forth. Now I need to remember that I'm totaling up my current total of items. So I have a variable in here called num item. Actually, let's call it num items, more accurate. So we'll say num items is equal to num items plus number of items. Not the string version of it, because I want the actual numeric number of items that this particular item name has. And I want to add that onto my running total of num items. All right, when this for loop is done, I'm going to print out total number of items, colon 62. So we'll go ahead and I'm going to print. Let's see. I'm going to actually show you F strings right now because I think they're pretty handy if I remember how to do them. Total number of items. What do I want me to say there? Colon. And then what I'm going to say in here is num items. I think that is how F strings work. So then down here, we'll go ahead and call our display inventory with our stuff. Not how F strings worked. No, that looks correct. Too many values to unpack. Okay, so it doesn't seem to be complaining about my. Oh, hold on. My issue is this. Dot items. Same thing we explored down here, that I could either enumerate it or I could say, give me the items from there. Let's just run this real quick. There's my inventory: 1 rope, 6 torch, 42 gold coins, 1 dagger, 12 arrow, and total number of items is 62. And I'll just bring attention to this last thing I did. I did something called an F string. This is a formatted string. So notice I was able to just kind of write the whole string that I wanted and kind of embed a little, placeholder instead of having to concatenate. So this is shorthand for this. See if I run this again, both of these give me that same output. So a formatted string or an F string is something that's available in Python 3. It makes concatenating things together for textual output a little bit friendlier. I think this is a pretty reasonable shortcut to use. It's actually something that's been around since even the C days for string, where you have placeholders for values. But, choose your poison. All right, is that it for display inventory?
Yes.
Okay.
No, there was. I think we covered it. I don't know. Yeah, I didn't know if this was related to the project or not. I did it anyways, but I don't know if
This guy, the list to dictionary function.
Yeah.
Yeah, that's it wasn't. So if you didn't do it, that's fine. But let's go ahead and do it real quick since we're right here. So if I have a list like this, so they're saying, we have the dragon loot. He has a gold coin, a dagger, gold coin, ruby. So the idea is you want to turn this into a dictionary that says gold coin 3, dagger 1, ruby 1, for the number of things that are in there. And we'll do that by having to check whether or not an item is, we'll pass in our current inventory, and then the items we're adding. So the idea is, you just killed a monster. The monster has dropped his valuables, and now you're going to add those things to your inventory. You might already have some gold coins in your inventory, but you're going to add 3 more of them from what the monster, in this case, the dragon, dropped. All right. Otherwise, maybe you didn't have a dagger before, and now you have 1 dagger. So we need to be able to ask the question, is something already in our inventory? If it is, then we can go ahead and add it. Otherwise, I think we can get a default value from dictionaries. Well, let's just start writing it, and then I'll look up how to get my default value. This would be a good practice for using the in operator. All right, so let's see. Add to inventory is what we're defining. And this guy's going to take in our current inventory. Really spell it out here. So it's the current inventory dictionary. And it's also going to take in a list of loot from the thing that we just killed, for example. And what we want to do is we want to go through every element of list of loot and add it to our dictionary. Okay, so we'll go ahead and we're going to have our for, call it loot item, in list of loot. So this will go through this entire collection here, where loot item each time through will be the next loot item in here. And then we're going to ask a question. I think there's a way to get a default value, but I'm going to just ask the question instead. I'm going to say if, let's see, loot item in, so I can hit that. Oh, look at that. Fancy. So if the loot item is currently in my inventory dictionary, if that's a true statement, then I'll say current inventory dictionary at bucket loot item plus equals 1. So that's saying current inventory dictionary at bucket loot item is equal to current inventory dictionary loot item plus 1. So it increases it by 1 because I found one more of those items here. Else, current item dictionary at bucket loot item is equal to 1. I have found my first one. Okay. Now we actually do not need to return our inventory because dictionaries are passed by address. So that means that I've made changes to it. So those changes will be recognized externally to this. So I already have an inventory here, right? With some rope, torch, gold coins. I have 42 gold coins. So if I were to kill this particular dragon, here's my dragon loot, which has gold coin, dagger, gold coin, ruby. So let's put that down here. So we'll say dragon loot is equal to, we're going to have a list of things. So we have gold coin, dagger, gold coin, and then what was the last one? Ruby. All right, so we just killed a dragon. I saved you all the gore from that, but this is what he dropped. All right, so I'll go ahead and display my inventory. Here, we'll display it before we kill the dragon. And then I'm going to go ahead and call my, add to inventory, passing it my current inventory, which is called stuff, and passing it my new loot, dragon loot. And then I'll go ahead and call display inventory of stuff again. And we'll see that we now have new coins and a dagger and a ruby added to our inventory. So here's 3 additional gold coins. Here's our inventory before the dragon fight. After our dragon fight, we now have 3 additional gold coins. We have 1 additional dagger, and now we have 1 ruby that we didn't have before. All right, that makes sense. So there is the code for doing that. But notice here that the inventory that was passed in, I did not return because I am actually changing this guy in its original memory location. I added 3 new coins to the original. I added a dagger to the original. I added a ruby to the original. I didn't at the end here have to return him and put him someplace else. Notice I did not say stuff is equal to whatever this guy returns. And inside of this guy, I didn't return a value. Dictionaries and lists are passed by address. So when we pass it and make changes to it, those changes have side effect. It's a permanent change that is noticed outside of that function. All right. Questions about any of that stuff? All right. Was that everything for the homework that was due today?
Yes.
All right.
The 2 drills in the project, yes.
All right. So now let's look at let me post this up on Slack, and then we'll look at what we have coming up for next week. We'll just replying to my text from my mom. She's checking on her little boy. All right. Slack a little bit though. 35. Let's see. This was drill 6-7.
6-7, yes.
And project 4.
And project 4.
All right. Here we'll see project 4 plus.
Drill 7-8, sorry.
Oh, 7-8. Okay.
Yeah.
And then I said project 4 plus since we
Yeah.
did a little extra stuff on there. Okay. Let's see what we have coming up next. So we have 7, 8, so 9, 10 is our next 2 drills, right? Let's look at what those guys entail. All right. Okay, implement the table printer project from end of chapter 5. Let's just go look at that real quick. I think that deals with like text alignment stuff. That shouldn't be a say chapter 5 or 6. Oh, end of chapter 6. All right, so here's our table printer. So the idea is we are going to take in a list. So this guy indicates it's a list. And a list is a collection of things. Each thing in this list is actually a list of strings. All right? And notice that each of these strings in this list have the same number of elements in them. So apples, oranges, cherries, banana, that's 4. Alice, Bob, Carol, David, that's 4. Dogs, cats, moose, goose, that's 4. So you can assume that you'll get a list of lists, and each list will have the same number of elements as each other. It does not specify what the longest value will be in each one. All right? So our print table function should go through, and it should print out kind of like a, think of it like a table in Excel. So there's some kind of like pretty printing, make it look nice on the screen. It should print out the contents of your table. So write a function named print table that takes a list of lists of strings and displays it in a well-organized table with each column right justified. All right, so we're going to go and look at what that means here in a second. Assume that all the inner lists will contain the same number of strings, like I just said. All right, so in this chapter 6, which I want you to read through, they introduced a whole bunch of different functions here. Let's just spin through it real quick, and I'll point out highlights as we go. All right, so this is talking about different string things. So I think you've seen me do this before. There's escape characters, so you can put a backslash before something. So in Python, you can use a single quote or a double quote for representing strings. Well, let's assume that you want a string that actually says Bob's mother in it. That is Bob apostrophe S. You don't want this single quote to be represented or to be treated as the end of a string. You want its contents to be part of this string. So you use a backslash before that guy to tell Python, don't try to treat this guy like something that's part of the language. Just treat it as a character. So that's what escape characters let us do. All right, so this will give us the string, say hi to Bob's mother. All right, here's some built-in escape characters. So you can have a tab, which is kind of like equivalent to hitting the tab key on your computer. \n kicks it down a line to like as if you pressed enter, return on your keyboard. and a double backslash is how you allow a backslash to appear in your string. All right, you saw me do something called an F string a few minutes ago, so it looks like they don't introduce that till chapter 6, but there's something called a raw string, and a raw string just says, go ahead and just treat everything that looks suspicious in here as a escaped character. So that means only the first and the very last quote will be part of the thing. So if you have a string with a whole lot of escaped stuff in it, you might choose to make that a raw string so that you don't have to do as much weird stuff inside your string. You can have multi-line strings. So one thing you've noticed so far is Python's very picky about indentation. So with that in mind, you might feel like you have to have everything on one line, because if you kick it down to the next line, then all of a sudden indentation is off. Well, Python allows you to use the triple quote, so this is 3 single quotes in a row, as a string starter, and it will keep going until you hit a closing triple quote and allow you to bridge across multiple lines. Same thing's true for comments. I assume they're going to multi-line comments. You could do a triple double quote and then write like a paragraph for a comment and then finish it as a triple double quote if you wanted to have some more stuff in there. All right, so indexing and slicing strings. Well, you've already seen indexing strings. So like in the string hello, the H is at bucket 0, the E is at bucket 1, 2, 3, 4, 5, 6, 7, all the way up to length -1. All right, so that's how we index a particular string. Oh, and here was that thing from before. I said for a string or any collection, you can get the last legal bucket. Let me see who's. Okay, yeah, not this class. I was making sure somebody wasn't sending me a Slack message saying something in class wasn't working on Zoom. Okay, so remember, strings are collections just like lists are. So if this was a list of numbers instead of a string, spam at bucket 0 will still be that first number. Spam at bucket 4 will be the 5th number. Spam at bucket -1 will be the last value. So this is kind of like a shortcut of saying spam at bucket length of spam -1. This gives you a range. So this will give you from bucket 0 up to, but not including 5. So similar to how the range function works. So this says only give me the first 5 characters of that string. This says, but starting at bucket 0. This is equivalent to that. If you don't put a number before the colon, it just assumes you mean start at the beginning. Otherwise, if you do put a number before that, it means start at that number and go up to the second number. So notice this one here says, give me everything starting at bucket 7 all the way to the end. So since we didn't put a second number there, this will take you all the way to the end. So this gives us the ability of getting substrings out of strings. It'll also work for getting sub-elements out of a list. All right, in and non-in operators, I just used this in our last thing. We can ask the question, this is a Boolean operator, is the string hello found in the string hello world? Yes, it is. The string hello found in hello? Yes, it is. Is the string hello all caps found in hello world? No, it's not. So it does match it. All right. Is the empty string found inside of spam, the string spam? It is. There is a string found in spam that has no characters in it. So that one's a little bit of a tricky one, let's say, because this guy is found in every single string. This will be true for any string. Cats not in cats and dogs. That's false because cats is in that string. All right. So the in and not in combo, let's say, allows us to ask questions about whether something is in a collection or not in a collection. So that's a handy tool. So again, as I kind of explained in class, as we go through, as we start learning about these tools, and I've even, expressed it to you tonight, is that, each language kind of has its own built-in set of tools. And I think Python is kind of notorious for having, I'm going to call it, too many tools. And part of the problem with that, I think, is actually that Python has gotten this reputation for being an easy programming language. So it's easier to pick up for people who haven't programmed before. And I'm not sure if I fully agree with that. I teach from the perspective that programming is programming, the language doesn't matter. So I'm not sure there is a such thing as an easy programming language. But having said that, whenever you find a built-in tool in a language, I like to think of that as kind of like you went to Home Depot or you went to Walmart and you bought something, and that something has a function, right? If you're going to make a smoothie at home, you use the blender. The blender is something you bought from the store, and if you throw a bunch of crap into the top of it and hit a button, it's going to give you a smoothie. That's what that tool does. So I like to think about all these functions that it gives us as various tools in the language. Or maybe I'm making the argument with Python that it maybe gives us too many tools, but I think the in and not in are perfectly reasonable tools. I'm more thinking about all the 50 different ways of doing the same stuff. I'm not sure that's necessarily handy, but in any case, this in keyword lets us ask whether something is in a collection. The not in combo allows us to ask the question and whether something is not found in a collection. Okay, yeah, this is what I talked about with this. This is either concatenation for building strings, or this is, I'm sure, yeah, here's the F string. Or it introduced F strings where it allows you to kind of more conveniently embed values inside of strings without having to do crazy concatenation. So that's handy. They introduced some more string methods, upper, lower, is lower. So upper and lower, these guys convert strings or return the string that is that string in uppercase or in lowercase. The other one allows you to ask the question whether something is all uppercase or something is all lowercase. So you can look at the examples for that. And you see here's a bunch of other tools that we could pick up off the shelf at Home Depot that allows you to ask whether a string is all alpha, so all alphabetic letters, whether it is alphanumeric, so numbers and letters, whether it's all numbers, so decimal, whether it has only spaces, whether it's a title, if the string consists of only words that begin with an uppercase letter. I don't know how well, I guess every now and then that might be useful, but this is probably bordering on one of those tools that I don't think needs to be built into a language. You could always just write your own little function that does that, but these are some things that are built in that may or may not make your life easier sometimes. I guess generally speaking, I would encourage you not to just go through and memorize these things. You can write a function that checks to see if every character inside of a string is one of A through Z or uppercase A through Z. You could create that code. You didn't have to memorize that this is something already built into the language. That function, once you're a competent programmer, that function is going to take you 2 minutes to write. And it might take you 4 minutes to go Google whether there's something already built into the language for solving that exact problem. Okay, so you can look through the examples for that. All right, joins and splits. So this allows you to join collections together. So this join here, we're going to join into a single string, and notice it goes ahead. You can give it a, you can join it on a value. So I'm saying I want to create a string out of this list. So cats, rats, bats is my list. And I want to create a string that has all those guys separated by commas and a space. So cats, rats, bats. Similarly, I can do a join just on a space. My space, name space, is space, Simon. So this will generate a string out of a list. All right, so get the point with that. Split ends up by default splitting on spaces. So this allows you to take a string and turn it into a list. The join takes a list, turns it into a string. Split takes a string and turns it into a list. So the default for split gives you each individual word, let's say, in your string separated into buckets in a list using a space as the delimiter. You can also choose to have other spaces, splits. So I can say I want to split this guy on A, B, and C. So I'll have the my name is Simon, because we had an ABC here, an ABC here, so on and so forth. Okay, so we can split on spaces by default or on whatever we want after that. This guy will split on carriage returns. We saw the \n before, so it kind of lets you take like a paragraph and get the individual, call it lines out of it. We also have something called partition, which is kind of like splitting, except it actually doesn't produce a list. It produces something called a tuple, which you would have read about earlier. Tuples are like read-only lists. They're lists you cannot change. All right, so notice this guy is saying, I'm going to partition the string hello world on the W. So notice it gives you 3 elements. It gives you the thing that comes before what you're partitioning on, the things that comes after what you're partitioning on, and then the thing you're partitioning on in the first place. All right, so it gives you all 3 of those pieces. Yep, so here's a shortcut thing where, since this is going to give you a tuple with 3 things in it, so the before, the after, and the separator, you can choose to say, I'm going to partition this string, and I'm going to store the results in these 3 variables. So before will equal the hello, the separator will equal the space, and the after will equal the world exclamation point. If that makes sense for what you're doing. These are, again, are tools that allow you to accomplish some things. I would say string manipulation stuff is pretty powerful. So being able to split and partition strings might be a fairly powerful tool. It's also something that's found in a lot of languages. So that maybe complements kind of what I was saying earlier, where I claim that Python maybe has too many special functions for things. But any function that is found in, let's call it 85% of all programming languages, is probably acceptable, because most programmers are going to kind of expect it to be there. So things like this, splitting a string up on some delimiter, that's common. So these are all, I'm going to call these are all reasonable functions for Python. All right, so then now we're starting to get into what this particular drill assignment is asking you about with right, left, center justification. These are things that I probably don't necessarily think are required in a language, especially modernly, since most of our programs don't necessarily give us text-based output, but I guess it's a nice convenience. So for instance, right justified says, here's a string hello. I want to create a string where hello is right justified, but I want that string to take up 10 spaces. So notice it expands hello instead of being 5 characters to 10 characters, but right justifies hello in there. Similarly, right justified 20 makes it a bigger string, so on and so forth. So you have left justified, there's going to be a center. So those are little tools that you can use to create your strings in a little bit nicer format. Notice you can also give it an optional second parameter to the justification things, where instead of it just being spaces, maybe you want it to be asterisks. So notice up here, it just made this spaces by default. But when I give it a second parameter, now instead of it padding with spaces, it padded with asterisks or padded with minus signs, so on and so forth. You can pad it with whatever you want. All right, here's the center, or center with an equal signs on either side. So it does a lot of that work for you. Stripping, right strip, left strip, and strip. So this is a lot of times in programming languages, it's called trim, is a pretty common term for strip. So that gets rid of white space before and at the end of a string. So you get a little bit more granular here with Python, which I think could be handy. So I would call this a benefit, let's say. So if I were to strip hello world, this will remove the spaces before hello and the spaces after. But if I only left strip it, it's only going to remove the spaces to the left side. If I right strip it, it's only going to remove the spaces from the right side. All right, so I can be picky about where I want to remove stuff. I can also strip things other than just spaces. So similar to above with the justifications, the default is space, but I can choose to strip anything that's an A, M, P, or capital S from the beginning or end of this guy. So this isn't a word. These are any A's, any M's, any P's, and any capital S's that are found at the beginning of your string. So as long as you're looking at something that's one of those 4 characters, it's going to strip it away until we finally hit this big B here that is not found in here. Then we're going to say, okay, we have left stripped this enough. We started on the right side, start walking backwards. We finally hit a lowercase s, which is not found in this set of 4. So we've right stripped it, and we're left with just bacon, spam, eggs. All right, so we have a lot of control over, like I said, in other languages, it's called trimming. So kind of cleaning up or formatting a string if there's some extraneous characters somewhere in there. Another tool, another couple of functions that sometimes might be helpful, sometimes might not. Most languages have convenient ways of getting at these values without having a special function. Python does not, so I'm going to call these functions okay. So the ordinal value, so for instance, if I say ordinal of the character A, this gives me the Unicode, numeric Unicode value of A. If I say give me the character for the Unicode value 65, it gives me the uppercase A. This allows you to view the Unicode versions of chars and also get a char from a Unicode value. Might be handy sometimes. Allows you to ask things like, does an A come before a B? That kind of stuff. Okay, this is teaching about a particular module that exists. You can go through and read about this, called paperclip for copying and pasting junk. That's not a Python specific thing. It's more of a handy thing that we might come back to and use in a later thing, but I'm not going to spend any time on going through that. All right, so it looks like we're pretty much at the end of chapter 6, and that gets us down to our table printer. So I write a function that takes in these things and displays it in a well-organized table with each column right justified. So we already looked at right justified things, and we also saw those values. So one thing you're going to have to do is you're going to have to go through all of these strings and find out which one's the biggest. That way you know how big you need to right justify with padding. So if your largest value here, if you have a character, if you have a string, I'm just eyeballing here, is oranges or cherries, look like it's the longest. 3, 4, 5, 7. So it looks like 8. So just eyeballing this, the longest string out of all of these is 8. So we'd want to have everything right justified padded by 8, because that guarantees that all of your values, so if we come down here, this is a space of 8 up to here. That's a space of 8. This is a space of 8. Notice it's right justified. Oranges were just a little shorter, so it had 1 space before it. Cherries takes up the entire space, so on and so forth. All right, so you'll have to have 2 pieces to your logic. Go through and find the largest string, then use that length to handle your padding, your justification for all your strings. Okay, it looks like they actually, just to take it a little step further, it looks like they do this among the first. So when they print these are, let's see, Apple, Alice, dogs, Orange, Bob, cats. are these guys separated? Yeah, so it's saying for the first column, the largest value is 8, so everything should be padded by 8. But for the second column, your largest string is what, David, 5? So David fills up the entire space. Carol fills up the entire space. Bob does not. He fills up only 3 of the 5. Alice fills up the entire space. So it's not 8 across the board here. It's per column. So for dogs, cats, moose and goose both have 5. So these guys take up their entire space here. And then cats and dogs are a subset of that space. All right. Oh, and they even give you a hint about finding the longest string and that kind of stuff. All right. So questions about that one, what you'll need for table printer. Okay. Let's see. Next one after table printer is drill 10, strong password detection from end of chapter 7. Let's look at what chapter 7 has in store for us. And are we okay just kind of powering through this and hopefully getting done in like the next 30 minutes? Does that sound reasonable to everybody? As opposed to taking a break? I'll take that as a yes.
Yes, sorry, I zoned out. Okay.
Oh, no, it's fine. It's fine. It's also possible that my audience had left me. So it's either way, I'm going to keep recording this. So I just figure if I go through the chapters and just highlight the important parts, that's fairly valuable since I don't want to take the time to show a lot of examples. But I also want to make sure that you have what you need. So this one should be pretty cool. This is actually a pretty powerful thing that a lot of programmers don't necessarily use very often. And I'd even admit I'm relatively out of practice with it, but it's super powerful and it's been around for 1,000 years. It's been around since the very, very early days of computing, and that's this idea of regular expressions and matching patterns. So let's flip through this real quick. And what was it? Strong password detection from the end of chapter 7. Okay. All right, so let's see, what do they do at the beginning here? Okay, so they're kind of saying, well, let's say you have something that looks like a phone number like this, and you want to kind of write a function that allows you to take in, let's call this a string, and return true if that guy is in a proper phone number format or false otherwise. Well, we could write the code that does that kind of walks through and makes sure that you have 3 numbers followed by a dash, followed by 3 numbers, followed by a dash, followed by 4 numbers. We could write the logic that does that, but it would be a little bit, let's call it tedious. But we have this idea of regular expressions that allow us to kind of represent patterns like this in a, let's call it initially somewhat funky way, but once you get used to using them, they're actually quite powerful and pretty easy.
Yeah.
I don't remember, some of my knowledge or memory of them is going to be a little rusty, but it'll catch up pretty quick here. But let's see, they'll probably show a pretty quick example early on. So I'm just going to blow past this because that's like manually checking it. All right, so finding patterns with regular expressions. So for instance, we can say, so a placeholder for a decimal value is a \d. So this says it is one of those. Backslash lowercase means it is one of those. So this means I have one decimal value followed by another decimal value followed by another decimal value followed by, and this is any decimal value. So this would be 0 through 9. So this is a 0 through 9 followed by a 0 through 9 followed by a 0 through 9 followed by exactly a dash. Okay, if there's no slashes or anything, it expects there to be a dash. Followed by a 0 through 9, 0 through 9, 0 through 9, followed by a dash, followed by a 0 through 9, 0 through 9, 0 through 9, 0 through 9. So this would be a accurate regular expression for matching our phone number in this format. You can also shorten this a little bit like this by saying I have 3 decimal numbers followed by a dash, followed by 3 decimal numbers, followed by a dash, followed by 3 decimal numbers, or 4 decimal numbers. So this guy right here is equivalent to this guy up here. Either one of them is legal in regular expressions. So you can pick your poison. This is pretty handy when you know you have collections of things. All right, so for regular expression objects, we're going to use a package that's part of Python called RE for regular expressions. So for example, we're going to create a regular expression object for our phone number, thing we just talked about. And here's the regular expression that we had in here. And notice that what does this R stand for? Anybody remember what this R stands for? What'd you say?
Raw?
Raw.
String?
Yep. Yep. So this is a raw string. So it says, don't pay any attention to these backslashes. I mean them. I want them to be backslashes. So if you imagine if this was a normal string, backslash is our escape character, right? So if this was a normal string, I would have to say backslash, backslash D, backslash, backslash D, backslash, backslash D, so on and so forth. But by putting the R in front of it, which has nothing to do with regular expressions, I'm saying treat this string exactly the way I wrote it. Don't, it's going to begin with a double or a single quote. It's going to end with a double or single quote. Everything in between, just leave it alone. It's exactly what I meant. All right, so this is my raw string representation for my regular expression. I'm going to use the regular expression library to compile that regular expression. It's going to effectively build me a pattern matcher that I'll then store inside of this variable. So this variable then becomes this tool that allows me to detect whether things are phone numbers or not. All right, so we can go and this is our match object. So this is the output of calling search on our regular expression phone numbers. So if I use my phone number regular expression thing that I created up here after I compiled it, and I use that to search the contents of another string, I'm asking the question, does this string here contain at least one match to a phone number? In this case, it does. We see something in there matches. All right, so the phone number that we found, we could ask the question if MO is equal to none. None would mean there's nothing in there. Otherwise, phone number we found is the group, which defaults to group 0. We'll talk about that in a second. I assume we'll talk about that in a second. It says the phone number we found was this phone number. So it detected one match to our phone number in that string. Okay, we can group things with parentheses. For instance, sometimes you care about the area code, and then you also care about the rest of the number. So you might care about the entire phone number, or you might care about the phone number in individual pieces. So we use our exact same phone number variable here, except we have some extra parentheses in here in our regular expression. These are not matching parentheses. So these parentheses here are part of the regular expression syntax that says, treat this as one group of my full match. Treat this as a second group of my full match. We're still matching this entire regular expression. But when we match it, I want to be able to piece apart the parts of it to maybe look at just the area code or look at just the number. All right. So again, we're searching within this string for a phone number. And then we're looking at group. So group 0 would be the whole thing. Group 1, so I said earlier, group 0, yeah, here's group 0 is the whole thing, that's the default. Group 1 is the first subgroup that we specified in there with our parentheses. So that's just the area code. Group 2 is the second subgroup that we specified in there, which is the rest of the number. I don't know what you would call that. So notice that group 0 and group give you the same output. All right, so this allows you to be a little bit more granular with your matching if there's certain parts of it that might mean something to you, like parts of an address, things like that, might want the zip code. You can also ask for the groups which will give you the tuple that has all the groups in it. So this is bucket 0 of this tuple is the 415. We can't change this. Tuples are read-only. And then bucket 1 is the rest of it. All right. Notice we can also use the shortcut we saw earlier, where we can create 2 variable names and set it equal to something that produces a tuple, and it will load into each of those variables are the part of that tuple. So bucket 0 goes into the first variable, bucket 1 goes into the second variable, so on and so forth. Little shortcuts. Frankly, if you never use this syntax in your life, I think that you would be fine. This isn't something that's super common in other languages, but it's pretty popular in Python. I'd call it I refer to these things as syntactic sugar, where you could just say area code equals mo.group1, main number equals mo.group2. And I think that's more expressive personally, but pick your poison. Okay. Now they're showing some built-in things. So these are some, you're gonna have to use escape characters in your expression matching if you choose to use any of these things. Like we just saw, opening and closing parentheses have distinct meaning in regular expressions over and above what the other things had in them, right? So that means if I want to match a parenthesis, I need to escape character that parenthesis because I'm actually matching the character that's a parenthesis rather than marking something as being the beginning of a group. All right, so all of these things have special meaning. A plus says 1 or more, a star says 0 or more, $, I think that is it begins with, but it might be ends with.
End of line.
Yeah, ends with. This is a placeholder for one optional thing. And then we're going to start dropping off from there. So, but through practice, you'll kind of, understand how all these things work. And again, if you want to match these individual characters, you just escape character them, just like we've talked about already. All right. So for instance, if we want to, well, we wouldn't use a raw string here, right? Because I'm saying I want to escape character the single quote here. Well, if I raw string this, actually that'll be okay because it'll raw string this. So you do want a raw string, but I don't have my matching parentheses. So this is the beginning of my group. This is the end of my group. So I've missed the closing parenthesis for compile. Multiple groups with a pipe. So a pipe is this vertical bar thing here. So we can compile. We're looking for things that are Batman or Tina Fey, apparently. So we have our match. We search in there. We have the string called Batman and Tina Fey, and notice that it just matched the first thing it came into. So it matched one or the other. And with an or, it fires the first time it runs into it. MO2, we can say, we could search Tina Fey and Batman. So we've switched it around, right? And again, it matches the Tina Fey because that's the first thing it ran into before it ran into the Batman. All right, so you can go through and look at the rest of examples with that. We can optionally match with a question mark. I mentioned that before. So for instance, you have Batman or Batwoman, but it would either be WO followed by man or not WO followed by man. All right, that makes sense. So this guy will match Batman or it'll match Batwoman, but nothing else. Because this group right here is marked as an optional group. It's either all there or it's not there. And this is a single one of these. Notice that matched the Batwoman here. Here is a example where you might have an extra space in your phone number. So here is your area code followed by a dash. So we're going to say that's required. The dash has to come right after it. But then it can be followed by really any other character. This is a placeholder for a character, but it's optional. It doesn't have to be there. Followed by your other stuff. So it'll still match your same strings without a problem. Oh, actually, it's matching. This is saying something different. I'm sorry. This is actually saying whether or not area code is required. So this says you have to give me your phone number. You can either give me your entire area code or you cannot give me your area code, one or the other. So you can't say 5 dash. You can either give me just the 5554242, or you can give me 3 decimal numbers followed by a dash before that. You get to choose whether this whole thing is there or not. It's optional for that whole group. Right. So you start to see the idea here that you'll get better with regular expressions as you start using them, through practice, but they allow you to, match patterns within things. 0 or more with a star. So this allows you to match bat woman. Well, this allows you to match Batman, Batwoman, whoa woman, whoa woman, whoa woman, so on and so fast. So, so this matches 0 or more woes in Batman. Right? So the star here means 0 or more. If that was a plus, that means it would only match if there was at least once. That would only match Batwoman or Bat Whoa Woman or Bat Whoa Woman or blah 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 blah. So those are powerful too, to say this either exists 0 times or 1 or more times. So this allows for that whoa to be there no times or 1,000 times. The question mark says the whoa is either there or not there once. The plus sign means the whoa is there at least once, but possibly more than one time. Yeah, here's the matching 1 or more with the plus. So this will only match Batwoman, but it will also match with additional woes in Batwoman. So this is whoa at least once, but you can have a whole bunch of whoa, 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 whoa in there. You can, just like we had above, when we were matching, 3 decimal numbers, this will match ha 3 times, ha, ha, ha. This will match ha 3 or 5 times. So this is 3 times or 5 times. Why has it got the third thing? I don't know why it has a third one of these.
Maybe it's 3 to 5. So 3, 4, 5.
Oh, this is 4. Yeah, thank you. Yeah, so this says matching it 3 times up to 5 times. So this is 3. This is, I was counting this as 5 twice. That's 4, and this is 5.
Okay.
All right. We'll blame that on the 102 fever.
What?
Yeah, it's that high.
Yeah.
When I went to the doctor today, they took it. It was 102. I don't know what that is in Celsius, but it's high. It's high. All right. Yeah, so that's the same thing as we saw before when we're saying match 3 decimal numbers, blah, blah, blah. It just gives you some other ways of doing this. When you do a normal search, you'll just get the first thing, but you can do a find all, which will give you the multiple groups. So this guy will give you the result. It'll find both of these numbers in there, for example. All right, so these are kind of your shortcuts. So backslash lowercase d is any numeric digit. Backslash uppercase d is any character that doesn't match that. So anything other than numeric digits. This is any backslash w is any letter, numeric digit, or underscore character. So this is matching things that are part of words, let's say. This is matching anything except those. This is matching spaces. This is matching anything except spaces, so on and so forth. So uppercase is anything but, lowercase is the anything. All right, so like this guy matches at least one number, but it could be more than one, followed by exactly one space, followed by at least one word character. Make sense? All right. You could also create your own collection of characters and say, I want this to match against those things. So you can create your own. This says not in this collection. So this guy is like, instead of saying, if the equivalent of slash lowercase d would be a list containing 0 through 9. The equivalent of slash uppercase d would be a list containing the caret and then 0 through 9. So you can make those yourself. So there's the built-in thing for, let's call it commonly used stuff, digits. I don't know about this letter, number. I guess this is alphanumeric, call it that. And then spaces, so these are built in, but otherwise you can choose your match case. What matches, what doesn't match. So the caret is doesn't match, without the caret is find stuff inside of that collection. So notice that, and it's not in, so this guy matches A, E, I, O, U, so this is all vowels. Right, so what do we get out of this? We get, this is all non-vowels out of the string. So the non-vowels out of the string Robocop are R, B, C, P. Out of curiosity, does anybody in here know who Robocop is? Or is that before your time?
Oh, I know it.
You know it? That was a good movies when I was a kid. Well, I'm not that much of a kid, but yeah, I mean, I was young. Less than 10. So it had to be, you must have watched them as old movies.
Yeah, exactly. RoboCop, exactly.
Yeah, I remember when they came out in the theater.
Like, of course, yeah, of course, I didn't watch it when it was out, but yeah, I know it.
RoboCop release date. I played the video games on Nintendo. Oh, really? 1987. I thought it was earlier than that. All right. Well, I think, am I the only one in the room who was alive? Let's call that a probably. All right. So, yeah, caret dollar signs. The caret was not. Dollar sign is ends with, right?
Caret is start of line, I think.
Oh, we use the caret up here as a collection. So this, the caret in this collection says not in these things. Down here, you could also use the caret symbol at the start of a regular expression to indicate that a match must occur at the beginning of the search text. So that's for like checking to see if something starts with a capital letter, for example, something like that. So you can specify, I'm only looking at the beginning of it. I don't care about stuff in the middle. Similarly, you can look at the dollar sign and see what happens at the end of it if you're looking to see if something ends with a certain thing. Maybe you're matching, you only want Word documents, so it ends in a .doc with a maybe a question mark. Sometimes you get docx's and things like that, but you can match those types of things. Wildcard character, a dot. This will match any character except for a new line. So this dot says it's not optional. You have to have something there, but it can be anything other than a new line. So that can be cat, that could be rat, that could be bat. Dot star says 0 or more of anythings. Okay, so this is a group that's, so this basically will give you everybody's first name and everybody's last name. But what sucks about this one is it gives you the opportunity to have no first name or no last name. So I would think this would be at least the plus sign, but whatever. So this will give you the collection of first and last names that it finds in here. So it's looking for the pattern that is first name colon followed by 0 or more things, last name colon followed by 0 or more things. All right, so here's like a summary of the different things that we talked about. That's for email addresses. Here, strong password detection. So this is this the project for next week? Or is this the second? Oh, that's the second drill. All right. So for our second drill for next week, strong password detection, write a function that uses a regular expression to make sure the password string is strong. So they're saying a strong password is defined as one that is at least 8 characters long, contains both uppercase and lowercase characters, and has at least 1 digit. So it says you might have to test against multiple regular expressions to validate its strength. So you might find it handy to break your expressions, your regular expressions, into partial pattern matching to see, does it at least meet this criteria? And then does it meet this next criteria, and so on and so forth. All right, so that is for drill 10. So next week it is 9, 10, 11, and 12, right? And then the next projects. So that's 9 and 10. All right, and then project 5 is implement a regular expression version of the strip project at the end of chapter 7. So again, that's working with regular expressions. That's this one right here. Write a function that takes a string and does the same thing as the strip string method does, which removes spaces from the beginning and the end. Okay, if no other arguments are passed, other than the string to strip, then white space characters will be removed from the beginning and the end of the string. Otherwise, the character specified in the second argument to the function will be removed from the string. All right, so you'll want to continue to whittle away your string until it doesn't match your pattern, something along those lines. So you're going to create a pattern that says this guy is still off, and then whittle him down from there. All right, and then let's see. Back to the drill. Mad Libs from 8. selective copy from 9. All right, so input validation. This is checking to see if you entered in the right kind of stuff. There's some modules that let you do some more validation stuff. I'll let you read through that. Here's one thing. So when you import something, so here is the actual library called PyInput Plus. And so the idea here is that maybe this library name is a little bit too long for you or something. So you can actually say, I'm inputting that as PYIP. So then from that point forward in your code, you can say PYIP instead of PyInput Plus, because I guess we're lazy. So, but that's what the syntax says. It gives you a way of kind of renaming a library to something easier to type or something like that. All right, and this guy allows you to conveniently validate things. Like I'm asking PyInput Plus to validate an input of a number, enter num, and this guy will allow you to input something and do the error checking for you. So you can read through that guy. We'll get down to the Mad Libs section here. Where's Mad Libs? Was it in chapter 8, or did I read the wrong thing? End of chapter 8. Let me just quickly check chapter 9 to see if there was a Mad Libs thing here. Yeah, well, this is at the end of chapter 9. So, let me edit this real quick so I have the right chapter in here. So, yeah, so frankly, I mean, you could look through chapter 8 there, unless this other thing uses that guy. Password, Mad Libs, selective copy, which is either going to be 9 or 10. And what's the other project? Chapter 10, okay. I would skim through chapter 8 if I were you. I mean, it's valuable, that's fine. This whole idea of, error checking, making sure the user entered in the right kind of values. But kind of the theme from earlier tonight is, whenever you have to use a third-party library for kind of pulling off something you could just write yourself, that's fine. And maybe it's popular. Maybe that's the go-to move for all Python projects for validating input. But I'll rarely rely on a third-party project for doing something kind of trivial like that. I'd probably just write it myself. All right, so this guy deals with file I/O, so reading stuff in from an actual file. So this is, dealing with your operating system, file paths, stuff like that. So we might have a path in Windows like spam, like the folder called spam, inside that a folder called bacon, inside that a folder called eggs. So this is the path in Windows. Let's just get down to a real example of. So here's a list of files we might want to open up: accounts text, details CSV, and invite docx. So we're going to go through all the file names in that thing, and we're going to print out the path of C:\users and then that file name. So this gives you the full path of that guy put together. And we'll see how they're going to use it. You'll end up doing this with Linux style paths since you're over on the Linux side of things. You can join paths together with a slash operator to kind of create a, like if you go into a directory, you can drop down one more and add that to an ongoing path. Just get some example code here. So here's our home folder, users al, and we have a subfolder called spam. So we can add on to our home folder that subfolder spam, which is in al's folder, so on and so forth. We use our string joins. This is just string manipulation stuff. Okay, current working directory, this tells you, so we're importing a couple of things. So we're importing the operating system itself. So this will work in, this is independent of which operating system you're working with. So it'll have the interpreter will have the Linux stuff built into it. If you're on the Linux side, CWD stands for current working directory. So if you were to print that out, it'll tell you this is where your code is currently running within. So notice at the current working directory inside your Python program is actually where your Python 3.7 is installed on your computer. Probably not the home directory that you were expecting things to be in, like maybe your documents directory or something like that. Notice you can use the operating system to change a directory. For you, you might change the directory to your home directory on Linux, and notice that that will permanently change your directory. Well, for this run of your program. Absolute versus relative paths. Absolute paths are the full working paths. So like on Linux, it'll be like /home/ your username. Windows, it'll be C:\users/ al or whatever. Those are absolute path names, where a relative path name operates off of wherever your current working directory is. So if I'm in my current working directory and I go /temp, that'll go up one directory and then into the temp directory within that directory. So it allows me to do relative paths to that. This is all just normal file system crap. Not even dealing with Python stuff really yet. Let's get to the actual file IO stuff. All this is talking about directory walking and getting the files in a directory, and which is all fine and good, but usually you're talking about, hey, I have a file that has some text in it, I want to read it in. File reading and writing process. All right, so this will allow you to write stuff out to a file, read stuff in from that file. So this isn't even in your program. This is just from the interactive shell for Python, just showing how you can read and write files. So this gives you the path to a local file called spam.txt. You're going to write hello world to that file, and now that is written. Then you're going to prove it's written by reading from it, but you could actually go and open up that file and see that it has changed. Let's get to our code. So here we can create a file handle by opening a file path from our home directory, and inside there, here's our hello text. So this will open up a file. Well, this will create a pointer to a file called hello text in our home directory. You can also give it the full path if we want. This is the relative path from our home directory. Notice Mac OS directories look a little different. Mac OS uses directories similar to Linux. So Windows, the NTFS file system is a C:" based file system, where Linux, Unix systems use these are POSIX file systems, use a / for your home directory or for the root directory. So C:" in Mac OS or Linux is equivalent to /. All right, so we can use our file handle to read in the contents of a file. You can think of the contents as a single large string. So we've already been working with manipulating strings quite a bit. You can also do something called read lines, which if you do that, this will give you, this is relying on you having carriage returns at the end of your lines. It'll return for you a list of the individual lines that are in there. Otherwise, you can read the file in its entirety and then split on the carriage return, and it'll give you the same thing. Writing the files, same kind of stuff. Make sure when you're done writing to a file, you close it. If you don't close it, then it hasn't actually saved. All right, so this is going to deal with binary files. So binary files using this thing called shelf. I've never used it before, but this is kind of like an early day version of if you want to have data persist over the running of your program, you can use a binary file to actually like store like your users' inventory. If we're thinking about our fantasy game from before, we might store their inventory in this file so that we can read it back in later on. So notice here that they have a, so they're getting the shelf thing. They're opening this binary file called my data. They're creating this list of stuff they presumably want to save, and then they're storing stuff in there under the kind of like a dictionary. So they're treating the file as like a persistent dictionary, and then they close that file. And then the next time you open up your program, you can open that file and then grab your shelf file at Bucket Cats, and that'll give you the list that was saved. That's if it's handy. I don't think the homework has you work with that, but we'll see in a second. But that's handy stuff. And that's just somebody else's library that has done binary file IO and made it act like dictionaries, which is perfectly reasonable. But so let's get down to, so here's Mad Libs. Create a Mad Libs program that reads in text files and lets the user add their own text anywhere the word adjective, noun, adverb, or verb appears in the text file. For example, a text file may look like this. So inside your text file, maybe it's called madlib.txt. You have this written. The adjective panda walked to the noun, and the verb and nearby noun was unaffected by these events. So this is kind of like a, well, they're called Mad Libs. They're supposed to be kind of funny type things, but any place we have an uppercase adjective, noun, verb, or adverb, these are placeholders for something we might want to get from the user. So then the program will, for each of these occurrences, it'll ask the user to enter an adjective. So for instance, silly, then enter a noun, chandelier, enter a verb, screamed, enter a noun, pickup truck. The following text would then be created. It would, change, modify that string. The silly panda walked to the chandelier and then screamed. A nearby pickup truck was unaffected by these events. So it's kind of a funny type thing. So this is working with file IO as well as string manipulation, as well as pattern matching. So you could use your regular expressions to determine the number of pieces of information you're going to need to ask the user about. So that could be handy. All right, so that's the Mad Libs question, which is from is that project one?
It's the first drill 8, I guess. Drill 9, I think. Drill
Drill
10.
11, drill 11. So, and then drill 12 is the second one, right? That's from chapter 9. So it's selective copy. Guessing, was that a chapter 10 thing? Yeah. All right, so let me update that. That's actually chapter 10. All right, so this is still using file IO stuff, but this is organizing files so you can copy stuff from one place to another. So this is, so shutil is for the secure shell, or just shell rather. Utility for doing things with the bash. I guess I assume that's what sh stands for, is shell. So this allows you to issue shell commands. So you can copy stuff from one place to another place. You can copy an entire directory tree instead of just a file. You can move stuff. You can delete stuff. Send stuff to the trash. So this kind of allows you to automate a lot of the stuff you would do with the mouse, you know, by right-clicking and say delete, or right-click and say copy or move, you know, that kind of stuff. So the examples in here will allow you to walk through the directory tree, just building on what they did in the last thing. And here's their selective copy. So write a program that walks through a folder tree. So you'll you know, take in the you can either just pick the folder that you want to walk through. Maybe it's your, you know, inside your home folder, a folder called temp or something. And it searches for files in that folder. So give me all the files in that folder with a certain extension. So maybe PDFs or JPEGs, and it'll move all these files from that location there into a new folder. So think about the utility of this. So maybe you have a downloads folder, for example. And the download folder, like if your downloads folder is like the folder on my computer, you have a zillion different file types that you've downloaded, but maybe you have a whole bunch of PDFs for articles you might want to read later. Well, if I just click on my downloads folder here, I have all this crap I have to go through and see different things. As opposed to, I can run my selective copy program, tell it to look in my downloads folder and move all PDFs from that folder into another folder called maybe my PDFs, something like that. All right, so that's what the selective copy program does. Again, remember the name of the book is automating the boring stuff. So that's something you could do by hand, walk through there, or you can search for all .pdf in a folder or something, but this will do it by automatically. Okay, so that is for drill 12. And then the last thing for next week is project. Filling the gaps from the end of chapter 10. Let's see if that's a true statement. Yep. So write a program that finds all files with a given prefix, such as spam, you know, anything that starts with a spam, and regular expressions might help you with this for finding file names that start with a certain pattern in a single folder and locates any gaps in the numbering, such as if there is a spam0.txt and a spam3.txt, but no spam2.txt. Have the program rename all the latter files to close the gap. So this allows you to have, whenever you have a big list of things that are supposed to be parts of something, to have them numerically ordered. So you're going to be searching for all files that match a pattern, then looking at what comes before. So you might treat this as a group, looking for all things that come before it, and then renaming files as necessary when something is off. Keeping in mind that spam0 jumping to spam3, and then maybe spam4, you would have to move 3 to 2, 4 to 3. So you're going to be potentially renaming a lot of files multiple times. So my encouragement to you for that one is don't try to get fancy with it and try to reduce the number of times you might rename the file. Whenever you see an error, update that thing, move all of your names to one smaller than they used to be, then run it again. Keep doing it over and over again until you find no gap in there. So yes, that seems like more work, but it's not you doing the work. It's the program doing the work, so who cares? All right, so that's the filling the gap question. Okay, so I think that covers everything that you'll need for homework next week. Any questions about any of that stuff? This is probably the first week where things are going to get fairly interesting. These projects aren't crazy complicated, but hopefully you're seeing there's a fairly big jump between where we're at this week to what we're doing next week in terms of complexity. All right, questions, comments, concerns, bribes? There, you can see my face and how dead I am. All right, so I'm around all week. I expect to be back on campus tomorrow, but let's see how I feel in the morning. I do have an evening class tomorrow night that I want to make sure I get to because they have presentations. But regardless, use Slack and email if you have questions as you're working through these things. And as before, I encourage you to work in groups to learn the material. So I know, especially now as these assignments are getting a little bit more complex, you might want to just as a class or as a couple of teams of 2, you might just choose to get together and work on the assignment together and just kind of power through it. I think that would be a good learning opportunity, especially as there's a lot of work due between now and next week, and we just don't have tons and tons of weeks of class to fit everything in. It's just an unfortunate reality of the situation, but deal. All right, so, but again, I encourage you to work in groups. If you need me to set up a Zoom meeting or something for you, because I think you can set up a Zoom meeting, but don't they kick you out like after an hour or something? I think there's some things for generic Zoom meetings they can only last an hour. But if you want me to set up like a study group Zoom meeting for you, let me know. I'm happy to do it. Just give you a link.
I think this is the TeamViewer thing that lasts an hour. I think Zoom is open because I used to use Zoom before.
Okay. There is some limitation to Zoom. Maybe it's recording. It's possible they only let you record for an hour, but there is a limit. Zoom definitely has a business model where they eventually want you to pay them. And Concordia has a license, so that's why if you need me to set up a Zoom thing for you, I'm happy to do that because my account has all of the stuff enabled or whatever. But in any case, because I know several people in class have some driving limitations where getting to campus might be trouble, but maybe getting into a group on Zoom would be sufficient because everybody can share screens and that kind of stuff.
Okay.
Well, otherwise I'll upload this video after I end the meeting, and then I will see everybody hopefully in person next Wednesday.